So for this chapter, I don't know how much of the lecture we're going to get through, but the notes are really good, you know. If you look at the examples, there's a lot of good stuff in there. So if you get stuck, look at that. All right, so what happens if you don't have a right triangle? Then you use the law of sines and the law of cosines. And how do you know when to use each one? Well, it tells you right there. So, in order to use, well, first of all, what is the law of sines? You guys remember? Sine A over A equals sine B over B equals sine C over C. This is the law of sines. Do you know why they call it the law of sines? Because there's sine in it. Every single year, there's always one or two people, they switch the law of sines and cosines. I'm not sure why. And then the law of cosines, c squared equals a squared plus b squared minus 2ab cosine c. It's easy to memorize these because look, angle A is opposite side A, B is opposite B, C is opposite C. How can you go wrong with that? And then the law of cosines, here's side C, there's angle C there, right? Now, you might have learned the other two forms of the law of cosines, but it really doesn't matter. Like, if you started with b squared, then b squared equals a squared plus c squared minus 2ac cosine b. See how? These are opposite, and these are just the other two sides, right? Anyway, the quiz on this, I believe, is Friday. It's Friday, yeah? So, I don't know. These problems take a little bit longer because you gotta use your graphing calculator, you gotta store values or whatever. So you gotta get proficient at that now. So, I'm not gonna even write this one. Get rid of that one. So how do you know when to use each one? Well, you only use these if it's not a right triangle. If it's a right, I mean you can if you want to, but if it's a right triangle, then you just simply use SOHCAHTOA, right? It's simpler. Okay, so when do you use the law of sines? Well, if you look at the notes, when you know two angles. In other words, ASA or AAS. If you do not know two angles, do not use the law of sines, because then you're going to be in trouble. But every year, students do. I don't know what. Okay, so let me give you an example. Suppose you have a triangle ABC, and you know angle A is, give me something, 67 degrees. Angle B is, I don't know, 54 degrees. And side A is 7. Find the length of side C. Well, do I know two of the angles? Yeah, so you're going to use the law of sines. Now, in order to use the law of sines, if you're going to find side C, you got to know the opposite angle here. You got to know angle C. Do we know that? Yeah, because there's 180 degrees in a triangle. So this plus this is, what is A plus B? 121. So therefore angle C has to be 59 degrees. You can figure that out. So now you can simply use the law of sines. C over sine. See, the thing, Mr. Park, it's still upside down, but it doesn't matter. You can just reciprocatize each one, right? So that whatever I'm trying to find, I put that in the top. Okay? So C over sine 59 degrees is equal to 7, which is the only other side I know, over sine 67 degrees. And then you use this. Of course, if you want to solve for C, you go C equals 7 sine 59 degrees over sine 67 degrees. Punch that in a calculator. That's your answer. However, there's no way there's going to be a problem this easy. This is probably going to be within a problem. So whatever answer you get here, you store it. Store it in, I would say C, because that's C, right? And then you're gonna never use a rounded value in another computation. So you guys gotta practice storing. Or if you guys are good at copying and pasting, I've never done it before, but just remember, if you're gonna copy and paste, make sure you copy and paste the correct thing, because there's gonna be a lot of computations that you have to do now. Now, when do you use the law of cosines? I guess I gotta put it on this side. When you know 3 sides, or 2 sides and the included angle. It's all in the notes right there. So, for example, suppose you have a triangle. I'm not going to even label ABC. Give me 3 sides. Go.
2.
What?
2.
2.
7.
7.
9.
9. That doesn't even make a triangle. Okay, come on. Okay, here. How come you can't make a triangle with these sides? Because the sum of 2 sides always has to be greater than the third. 2 plus 7 is not bigger than 9. So why don't we just change the 2 to a what?
1.
Then that's even worse.
4.
Okay, 4. Thank you. Okay, find the measurement of the largest angle. Well, first of all, which one is the largest angle?
Top.
Yeah, the one that's opposite the longest side. So find the measurement of this angle. Now, if you want to label things like, Mr. Park, if I'm going to use this formula, then this should be C, right? Then this would be A, and this would be, I mean, if you have to do that, go ahead. But the way the law of cosines work, right, you guys learned last year, you don't need it. This is the angle you're trying to find. Okay, so how do I start the law of cosines? Do I start it with 4 squared, 7 squared, or 9 squared? Look at the formula. Look, this angle is opposite this side. So since this is the angle I'm trying to find, don't you start with this one then? So you just go 9 squared is equal to 4 squared plus 7 squared, right? That's the other 2 sides, minus 247 cosine of the angle. But like I said, if you have to do this, C equals this, A equals this, B equals that, so this is angle C, plug it into that formula, and there you go, you get the same thing. It really doesn't matter. So let's do, now remember, you get to use your calculator now, so don't try to do things in your head, because if you do it wrong, big points are coming off. You know why big points? Because you have your calculator. There's no excuse here. So, what is 28 times 2?
56.
In fact, you know what? If you have your calculator, just do this. 2 times 4 times 7 cosine theta is equal to 4 squared plus 7 squared minus 9 squared. You don't have to do anything, just let your calculator do everything. So cosine theta is equal to 4 squared plus 7 squared minus 9 squared all over 2 times 4 times 7. So take out your calculator, and then how do you figure out this angle? Punch in this number, and then, so what is theta? Cosine inverse. 4 squared plus 7 squared minus 9 squared all over 2 times 4 times 7. Punch it in on your calculator, and if I ask for degrees, give degrees, and put your calculator in degree mode. If I ask for radians, then put your calculator in radian mode. So you got to be able to switch back and forth between degrees and radians now. Oh my goodness, we only got 4 more minutes. Okay, so these are 2 simple examples. But like I said, on the quiz, this is just going to be part of a problem, as you'll find out. So then you probably got to take this answer, store it, and then use it in another computation. Okay, so the last case is, do you guys remember the ambiguous case? Really? The ambiguous case. That is SSA, because we don't want to write ASS, right? Sounds bad. Anyway, if you are given 2 sides and an angle that's not between them. This is the ambiguous case. What does that mean? That means you can have either one solution, start over. 0 solutions, 1 solution, or 2 solutions. Does that sound familiar? That's what happens when you purge, people. Okay, we got 3 minutes to take care of this. Let's see if we can do it. So, most books, and the way I like to do it, so the given angle, I always put it on the lower left-hand side. If you look at the example there, okay, give me an, okay, so why don't we call this A, B, C. Okay, so let's say the one angle you're given is angle B, let's call it what, 28 degrees. And then the other two sides, so this is, okay, why don't we call this 7 and 4 then? Oh, that's not 4. Find the measurement of side A. Now, there could be 1 solution, 2 solutions, or no solutions, but come on. Remember last year on the quiz, in fact, the teacher showed me your quiz. Remember you had to determine how many solutions there were? 0, 1, or 2? Oh my goodness. Okay, you know what? The book shows you how to do it one way, but that's really not the most efficient. If you look at any trigonometry book, you know what they tell you to do? They tell you to compute the length of this altitude and then compare this side with that. You can do that if you want, because that's the way you learned last year. That's the way your teacher taught you, but I'm going to teach you a better way. Use the law of cosines. See what your book tells you to do is compute the length of this altitude and then use the law of sines. Does this look familiar? Because this side could be swung on this side, and that would be 4 as well. Does that look familiar? Then you have 2 solutions. But you know what? Don't do that. Just use the law of cosines. That's the easiest thing. So if I'm going to use the law of cosines, what do I start with? This is the only angle I know. You start with this one, the one that's opposite from it. 4 squared is equal to a squared plus 7 squared minus 2a7 cosine of 28 degrees. What kind of equation is this? Look, you got a squared and you got a. This is a quadratic equation. How do you solve any equation on your calculator? What do? You make one side 0, a squared plus 7 squared minus 2a7 cosine of 28 degrees minus 4 squared. Graph that on your calculator. Of course, when you punch it in on your calculator, you punch an X in, don't punch an A. And then, what if your calculator shows this? You have 2 solutions. Those are your 2 solutions for A. What if your graph looks like this? Then you got no solution. What if your graph looks like this? Then you only got 1 solution. What about this one, Mr. Park? Well, how can a length be negative? Cannot, right? So this is a much more efficient way of doing the ambiguous case. Okay, I'm going to tell you right now, this problem is on there. All I'm going to do is just change these numbers. You just got to prove that you can do it. Okay, the bell's going to ring in like 20 seconds. So you really got to practice this now. You got to be good on your calculator. Okay, we're done. Okay, see you tomorrow. Okay, see you tomorrow.